Welcome to Lab E, Experiment 4, Density Determinations. We're going to look at density basics as an analytical tool, and we're going to use a calibration curve to determine concentration of an unknown. First part of the lab, we're going to look at the density of an irregular shaped object. Of course, to do that, we're going to need two things: the mass of the object, which will be determined by placing the object on a balance pan and accurately recording the mass. And the other is to determine the volume, of which we will do as we did in the prior experiment. We will determine the volume by difference. Everything in this lab, up to the calibration curve part, you will have already learned in either the mass lab or the volume lab prior. Here you see the initial volume in the graduated cylinder without the stopper. That's your initial volume. And the next volume you're going to see is the volume after the stopper is placed into the graduated cylinder. And the difference between those two is the volume of your stopper. It's now time to repeat that same experiment only for object B, which instead of a rubber stopper, it will be a metal rod. With these measurements, you can now complete all of Part A for both objects, stopper and metal rod. Next, we're going to determine the density of a liquid, and it's a sodium chloride solution for which you do not know the salt concentration. So what we're going to do is we're going to measure the density, and density correlates with weight % salt. So if one can determine the density, one can then determine indirectly the amount of salt using a calibration curve. That's where we're headed, but for first, you've got to get the density of the liquid. As usual, you're just going to need two pieces of data. You're going to need the mass of that liquid, and you're going to need the volume of the liquid. The volume is going to come from a direct reading of your Moore pipette, final initial and volume initial. And your mass is going to come in the form of an empty beaker and an empty beaker with the water in it. Again, these are the same principles that you've learned in the mass experiment and the volume experiment. now have all of the data to calculate the density for the unknown liquid. You've done it twice, so those values should be relatively close. Take the average, and now with that density, you can use what is called a calibration curve to determine the weight percent. This particular calibration curve shows the linear relationship between density and weight percent salt. For every time the density goes up, the weight percent salt goes up proportionally. So here's how you use it. You place a little tick mark along the x-axis, which corresponds to your average density, and then you draw a vertical line straight up until it crosses the calibration curve. Then you take that and draw a horizontal line until it crosses the y-axis. And where it crosses the y-axis, that is the weight percent salt. For this example, not your data, but for this example, it turned out to be 16.5%.